So today we'll be dealing with question 2 of the Wassce Physics 2023. Alrighty, now we're dealing with question 2, which talks about a satellite which orbits the Earth in a path of radius r. First, we're to name two forces that act on the satellite. Then we show that velocity is inversely proportional to the square root of the path of radius. All right, that's capital R. All right, well, as you know, a satellite is basically a celestial body which moves around a relatively larger body. The Earth is a satellite to the sun. So the first thing you ought to know is that there is a force between a satellite and the Earth. Now, the satellite has a mass of its own, the Earth has a mass of its own, and the path of which the satellite inscribes around the Earth takes the shape of a circle. Now, the radius of that circle is the path of the radius r. So you can see in my diagram here, the path of radius is right here. This is the satellite we have. Then this is Earth. So now the satellite is the smaller body, then the Earth is the bigger body. So this satellite is moving around the Earth, just as the Earth also moves around the sun. So let's look at some of the forces which would be present in this particular situation. We have the satellite moving in a circular manner, but it's not moving away. You can see that the force of the satellite is directed towards the Earth. So there's a pull. There's a pull from the satellite towards the Earth. Now, this pull is due to a force which is found between them because of their masses. Now, the force found between bodies, mainly due to their masses, known as gravitational force. All right. Now, apart from the gravitational force, because the satellite is moving in a circular manner and its force is directed towards the center of the circular path of which it inscribes, it possesses something known as centripetal force. All right. So, how do we solve this question? Name the two forces that act on the satellite. 1, gravitational force. 2, centripetal force. All right, it's fine. So now we're aware of the two forces that were acting on the satellite. Let's look at how the velocity v of the satellite is related to r by the expression v is inversely proportional to the square root of r, or v is directly proportional to 1 over the square root of r. Now, the two forces that are involved here, in order for them to work hand in hand, they must be equal. All right? The centripetal force comes mainly from the gravitational force. So we can equate them because it's because of the gravitational force that we have the centripetal force. All right? It's kind of similar to Niels Bohr's model of the atom, where the electrostatic force gives the centripetal force of the electron. Here we're not dealing with charges, rather we are dealing with masses. So the centripetal force is mainly due to the gravitational force between the two bodies. All right. So how do we go about this? Gravitational force is equal to the centripetal force. right? Now, the gravitational force is between the satellite and the Earth. So we have G, M, E, G, M, S, all over R squared, all right? Then now, what is the centripetal force of the satellite? That would be the mass of the satellite times the square of the velocity of the satellite all over the radius of orbit of the satellite. So yeah, your gravitational force is G m1 m2 over r squared. Here, the r is the radius between the Earth and the satellites. That is the radius of orbit. Notice how my radius stems from the center of the Earth to the center of the satellite. Why? Because gravitational force is dealing with masses, all right? And the mass of a body is concentrated at its center. Okay. So now what do we have? Let's see what we can cancel out here. The ms will also cancel out the ms. 1r will cancel out 1r here. So now we have G me over r, which will be equal to v squared. So now we simplify. V would be equal to the square root of G me all over r. Now, this can be simplified and be made square root of G me times 1 over square root of what? R. This will be your constant, all right? Now, if this is your constant, V will be equal to K times 1 over root of R. V will be directly proportional to 1 over the root of R. It's as simple as that. These steps are not that necessary, all right? From here, you can get directly to this place based on how mathematically inclined you are. But if I were you, take the safe way out and make sure you simplify each step of the way. This will give you a total of 3.